Hello and welcome to section C.1. We're looking at inequalities here, like equations, but less equal. So that means like when things are less than other things or some things are greater than other things. So here's a quick review of what these symbols mean. This means you read it from left to right, x is less than y. Another way to remember it is that there's the big side here, and right here there's just this little side. So whatever's on the big side is the greater thing. And greater here always means to the right on a number line. So let's see, if you have x is greater than or equal to -3, then on a number line, if there's 0 here, -1, -2, -3. And then we got -4, -5, and such out this way, and positive numbers over here, like +3. Okay, so saying x is greater than or equal to 3 means x is to the right on a number line. So that includes numbers like 4 and 5 and 6 and everything out that way. But it also includes negative numbers like -1 and 2. So to draw the solution set on a number line, I'm just going to shade the -3 here and also shade the rest of this stuff. So I make a big dot at -3 to show that that's the edge. And if we have this kind of thing where the t is in the middle of these two numbers, that's like this situation. If you have x is less than y and y is less than z, that's what this is saying. It's saying t is greater than -10 and t is less than or equal to -2. So it's in between -10 and -2. So on a number line, you might want to draw 0 over here somewhere. We have -1, -2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's -10 right there. -2 would be right here. So we want to include t equals -2. -2 itself is a solution of this because -2 is less than or equal to -2. And so is everything in between here. Anything less than or equal to -2 until we get down to -10. And then at -10 itself is not a solution because if you plug in -10 here, -10 is not less than -10. And this just says strictly less than, not less than or equal to. So to show that, you use an open circle at that point. So that includes numbers like -9, -9.9, -9.9987564321, anything that's really close to -10. Okay, so, and it has to be, t has to be both of these things, both greater than -10 and less than or equal to -2. Because if it's just one or the other, then that might include like 0, because 0 is greater than -10, but 0 is not less than -2, so it doesn't count. This is a little different. It says or here instead of it being and, like with this in-between notation. When you say y is less than 3, or y is greater than 7, or you could say 7 is less than y, it means the same thing. So let's see, 1, 2, 3's right here. So we're including anything less than 3. Which means all that stuff out there. And anything greater than 7. So that includes stuff like 7.1 or 8 or 12,000, anything out in that direction. is greater than 7. And I use, again, an open circle there to show that 7 is not included, but a big solid dot for 3 there. Okay, so that's what we mean by the solution set. It's all of the values of the variable, either x in this case, or t in this case, or y, that make this true. Okay, so these exercises here are good ones for you to pause the video here to do it yourself. These are definitely important to help you understand some of these concepts about inequalities. So let's pause it, and after I stop whistling, I'll show you the answers. Okay, so let's fill in this table. Plugging in x equals 0 here gives you 10 minus 0, which is 10. X equals 1 is going to give you 8, and so on. I'm just going down by 2 every time because I know the rate of change is -2. Alright, so that's that. Now, I also want to graph y equals 10 minus 2x and y equals 4 on your calculator or on Desmos.com. I'm going to go over how to do it on Desmos because it's a little bit easier to see when you are watching a video like this. The calculator doesn't have much resolution. Okay, so we are graphing y equals 10 minus 2x and also y equals 4, was it? Yes. Okay, so here's what these graphs look like. Let me make this window a little smaller so you can see the whole thing. I'm going to make sure you can see what I'm typing in on the left over here. Okay, so I'm going to take this part of the graph and paste it over here so I can write on it. Okay, so we have y equals 10 minus 2x is this red one, and y equals 4 is the blue one. Now, which one of these is the solution set? Let's use both the table and the graph, the solution set of this inequality. So what we're trying to do is we're trying to make 10 minus 2x greater than 4. So let's see. Let's look at the table. What are the values of x that make this true? Well, if x is 0, then that's a solution because that would give you 10. I'm actually going to make these red to be consistent with the colors on the graph. There we go. Okay, so yeah, if x is 0, that y would be 10, and 10 is greater than or equal to 4. So that's a solution. How about 1? If you plug in x equals 1, you're going to get 8 on the left side here. And is 8 greater than or equal to 4? Sure is. So is 6. 4 is not great. 4 is greater or equal to 4, but it's not actually greater than. But that's okay, because 4 is greater or equal to 4 is what it says. So, but is 2 greater or equal to 4? No. Whoops. That's the wrong one. Why? No. I want an x. Excuse me. There's my x. Okay. So those are not solutions. And you can see that from the graph here. What the question is asking to solve this inequality means find what are the values of x that make the 10 minus 2x greater or equal. And it's these points over here, where these values of y, the 10 minus 2x values here, are greater or equal to 4. And that corresponds at this point here is where x is 3. So the values of x that make this true, that make the red one greater than the blue one here, are where x is less than or equal to 3. So this is the solution. Okay, so let's look at exercise 2. If you understood exercise 1 and you followed along with what I was doing, but you needed to see the video to do it, then let's pause it now to try exercise 2 on yourself, because it's the same idea, but getting more practice will definitely make you better at it. But I'm going to assume you've done it now, and I'm going to go ahead with the answers. This is going to give you -6, excuse me. 6 minus 12. This is going to give you -3. This is going to give you 6 minus 6.03 is going to give you -0.03. This one will give you 0. This one's going to give you +3. Okay, so that's the table, and then let's make a graph of it. Go to desmos.com again, and we're going to have y equals 6 plus 3x. Looks like that. And then y equals 0. Well, y equals 0 is just the x-axis that you can see there. So try to shrink it so it'll fit in our little frame here. Let's see. Okay, so yeah, we have y equals 6 minus 3x in blue and y equals 0 in green. And what we want to know is, what are the values of x that make this true? That's what it means to be the solution of this. Is it x is greater than -2, greater or equal to -2, less than -2, or less than or equal to -2? So let's start with the graph this time. You can see at x equals -2 is what makes it be equal to 0. So that the fact that this point right there is on the x-axis, that means if you plug in x equals -2 into this, you're going to get 0 is less than 0. And is 0 less than 0? No. So that means x equals -2 is not a solution. So these ones are all out, the ones that have the or equal to. Now, is it less than or greater than? Let's see. Well, where are the y coordinates of the blue one less than 0? Well, the y coordinates are less than 0 when you go down this way. Like, here's where y is -2. Here's where y is -1. Y is -3, a little bit over here, but it doesn't quite show it here. So at these points is where y is less than 0. And what are the x values? That's what we're trying to find here, is the x values that make that true. So that's going to be x is -2. It includes, sorry, not actually equal to -2. Computer troubles. Not actually equal to -2, because that gives you 0. But -2.01 is good, because -0.03 is less than 0. So is x equals -3, x equals -4. All of these values of x out here are solutions. So that's x is less than or equal to 2. And you can see that, yeah, in the graph. These values of x are solutions. These ones, not so much. Okay. Now, the next video, we're going to do exercise 3. but you're going to do exercise 3, and then I'm going to help you get unstuck or help you check your answers. Talk to you then.